Okay, so this chapter discusses neurophysiology, which is the electrical and chemical processes that occur in the brain. So we'll start off talking about electrical signals in the brain. And so we talked about how ions at rest in the brain are unbothered, and they mostly consist of anions, which possess a negative charge, and then the rest consist of cations, which have a positive charge. So intracellular fluid is separated from the extracellular fluid by the cell membrane, which is made up of a lipid bilayer, and the ions are dispersed in the intracellular fluid. So in order to find resting potential of a cell, microelectrodes are used, and they are able to detect difference in charge across the membrane using a voltmeter, and it shows the resting potential, like I said. So some channels in a cell stay open, which allows things to flow freely without, and some open and close depending on the potential and everything like that. So the ones that do open and close allow potassium ions to enter only some of the time, so it is selectively permeable. So molecules tend to move down their concentration gradients, which is diffusion. And the sodium-potassium pump uses a lot of energy, and it pumps out 3 sodiums of the cell for every 2 potassium ions that are moved in. So equilibrium is reached when an equal amount of positive charge and negative charge are dispersed throughout the cell, and the amount of positive charge going in is equivalent to the amount of negative charge going out, or vice versa. So equilibrium potential is a little bit different. This is voltage distance across a permeable membrane. So this is calculated through the Nernst equation. So the only issue with the Nernst equation is that it assumes neuronal membrane is permeable only to potassium ions, but in fact it's actually permeable somewhat to other ions. So another equation that accounts for this issue is called the Goldman equation. So that equation shows how much a cell membrane is permeable to each ion that is able to flow in and out of it. So neurons also store calcium ions, which is used for intracellular fluid.